So this is what we're doing now. We are rewriting a filter as a sum of upsampled version of its phase shifted and downsampled impulse response. So we see we have there is the phase 0, phase 1, and so on. So here this H0 contains the coefficients of our original filter at positions at m times capital N. So this is phase 0. Then this H1 contains the coefficients at position m times capital N plus 1. So this is the phase 1. And in general, we will have the H of I, z to the power of n, which will contain the coefficients at position m times capital N plus 1 at phase I, plus I at phase I. So this means that the H of I of z is the z transform of the impulse response of m times capital N plus y, I. So this is H of n is the impulse response of our original filter. So this is some kind of a polyphase decomposition that we are rewriting a filter as a sum of upsampled versions of its phase shifted and downsampled impulse response. So it can be seen that there are many phases of our impulse response. So the components, each one of these components are called polyphase components. So this is just to illustrate, as an illustration, we see a simple time sequence, and then the sequence for a sampling factor of n equals to 3 that will be decomposed into 3 upsampled polyphase components. So first we're taking 1, 4, 7, 1, 4, 7, and we have zeros in between. Then we have 2, 5, and 8, and we also have these 2 zeros, or we can have also this 3, 6, that is shown here. So the upper plot, so this is the phase 0, the middle is phase 1, and this is phase 2. So the same can be done for our signal x of n. So our polyphase component, h of I, is the z transform of x m times capital N plus I.